When looking for a greatest common factor, it's important to keep two things in mind. We're going to look at the values or the coefficients multiplying our variables, and then in a separate thought process, we're going to look at the variables. So when we're talking about a common factor, what we're saying is what value is divisible, or what value would go into 6, 10, and 14? What do they all have in common? So you can do it piece by piece by just looking for easy values. So 6, 10, and 14, well, I know 2 goes into all of those. 2 goes into 6 3 times, 2 goes into 10 5 times, and 2 goes into 14 7 times. And then with our new coefficients, we repeat the process and we say, is there any value that goes into or divides 3, 5, and 7 evenly other than 1? And the answer is no. So we're done. But now we focus on the variables. We say we have x to the fifth, x cubed, and x squared. So the question is how many x's can I factor out? How many x's do they all have in common? And the lowest amount would be x squared. So therefore, I'm going to factor out x squared out of each term. So if the first term, the 3, notice the coefficient stays, the x to the fifth, I'm factoring out 2 of them, then that would leave me with 3 of them. Because remember, when we multiply variables, x to the fourth, for example, times x to the seventh, what is the rule? Well, the exponents add, making that x to the 11th. And a simple, whenever a student asks me, how do you remember that rule? Just think about x times x. What is that? Well, that's x squared. You don't get that by multiplying those exponents. You get them by adding them. So just a quick refresh. Here we go. So therefore, if we have x to the fifth and we're factoring out 2 of them, that would leave us with x cubed plus 5x plus 7. And we have now factored the greatest common factor out of the polynomial. And there is no equal sign, so therefore there is no solving. So your answer is exactly how it looks.